Welcome in this video where we are going to answer a question from my ebook on machine learning interview questions. I will put the link of the ebook in the description. Will you be interested? On here, this question is about combining labeled data on unlabeled data. Okay, so let's assume you only have a few labeled data and also from the same. Well, for the same data set, you have also a vast pool of unlabeled data, okay? So you have a large amount of unlabeled data, a few amount of labeled data, and the question is how do you maximize your model accuracy by leveraging the unlabeled data, okay? So here you should directly think about semi-supervised learning, right? That's really a semi-supervised learning scenario. That's really the definition of semi-supervised learning. You have a few labeled data, a lot of unlabeled data, and the idea is to leverage unlabeled data to increase the model accuracy, okay? So basically from now on, once you've recognized the semi-supervised learning setup, you can go with any solution, okay? Semi-supervised learning is a big part of machine learning. You know, there is supervised learning, unsupervised learning, and semi-supervised learning. That's really a big field. There are a lot of solutions. You can come up with any solution, okay? For example, I recently made a video. I will put the link in the description. Here, that's the testing accuracy is a function of the number of epoch when we train on only 100 MNIST example, okay? When you test on the 10K MNIST test set, you get only a 70% accuracy if you just do a supervised learning on the 100 labeled. But if you leverage unlabeled data, so the 60K unlabeled data plus the 100 labeled data, then when you combine those unlabeled data with the labeled data, you get a 20% increase in accuracy, okay? On here, this semi-supervised learning technique was combining GANs with classifiers, okay? So here we're not going to focus on this solution. I'm going to propose another solution, but again, there are hundreds of solutions. So what you can do, for example, is to combine autoencoders or variational autoencoders with a classifier. So first, you encode your data into a latent space by training an autoencoder or VAE. So you train your autoencoder or your VAE in an unsupervised way. So you train that on the full unlabeled data. And then you do the classification. You train the classifier in the latent space. So you take the labeled data, you encode them in latent space, and you do the classification in latent space because it's relatively easier to do it in that space with reduced dimensionality. In a way, you've done some kind of feature learning. You've learned some features in a lower dimensional space where classification is easier to do. What you could do, you could also fine-tune jointly the autoencoder plus, well, the encoder part of the autoencoder plus the classifier. I don't think it's necessary. So basically in my next video, we're going to implement that. You will see by doing that, you will get a 15% increase in accuracy than by just training directly a classifier on the labeled data. So you have really powerful semi-supervised learning, SSL. In my ebook, I also present all the solutions. Here, I will not go through them, but if you're interested, you can have a read at those. There are also a lot of references associated to each of those methods. So if you want to read the machine learning papers associated to them, I would advise you to do so. These are very nice papers. So I really hope this video was helpful to you. Again, in my next video, we're going to implement it. So subscribe or stay aware for seeing the video. Leave a thumbs up, comment. It's really helpful for the algorithm. It helps me to create better content. And subscribe for more content related to machine learning. Thank you.